Okay, so this is 8.1 part 3. If you haven't watched the first 2 parts, please go back and do so. So we're continuing on with frequency distribution tables, but this time around we're looking at grouped frequency distribution tables. And with a group frequency distribution table, this is used when we have a lot of people or a lot of things that we're looking at. And it might not be feasible or make sense to have, one number at a time. So what they came up with is what's called grouped frequency distribution. And what we're going to use is called class intervals. Okay, so class intervals mean that we have numbers in a class width, and each width is equal. And each data value must fit into one of these, and only one class. There's no overlapping. And there are preferably between 5 and 10 classes. So each class width has what's called an upper and lower class limit. And we need to fix this. So if you have the old notes, it is not fixed. So it shouldn't say upper limit minus upper limit. It should say upper limit minus the lower limit. So let's fix that in our notes. And now we're going to construct a frequency distribution table that shows grouped frequency. So this is going to be a number of individuals. And then this is going to be the frequency. So let's say, there's a neighbor turkey trot. And let's say the people are aged from, from like 10 to 70 or so. So the first class width is going to go from ages 10 to 20. Okay? That's called a class width, because if I am 17, I'm going to fall into that class width. And the upper limit would be 20 and the lower limit would be 10. Okay. So the next width up, and first of all, we need to know how wide the width is. So if we take the class width, I'm going to take 20, which is the upper limit, minus 10, and I'm going to get 10. Okay? So the next width up, I'm going to write 21. Notice I didn't write 20 again because we can't have any overlapping. And then I'm going to go up 10. So that would give me to the value 30. Because check this out. 21, 22, 23, 24, 25. That's 5. 26, 27, 28, 29, 30 is 10. Okay? All right. Now I'm going to do 31 to 40. Now I'm going to do 41 to 50. 51 to 60. 61 to 70, and 71 to 80. Okay? Now frequency, again, I'm just making this up. I'm going to say these are runners or walkers of a turkey trot. So let's say there were 525 people that were aged 10 to 20. Let's say there were 712 individuals that ran the race that were aged 21 through 30. Let's say there were 602 31 to 40-year-olds. And then, let's put in maybe there's a lot of middle-aged people. So let's put 1,021. 51 to 60, let's say there were 600. 61 to 70, let's say there were 525. And 71 to 80, let's say there were 210. Okay? So, again, with class width, usually the frequencies are larger. So let's answer the questions. What is the first class? The first class is 10 through 20. So again, 10 is the lower limit. So we can put 10 here, and the upper limit is 20. And what is the class width? Again, we take upper minus lower limit. So 20 minus 10 is 10. Okay. All right. So let's look at the next example. The board of directors at a small town golf club wants to conduct a study to determine if the golf club members are interested in remodeling the clubhouse. There are 4,500 people living in the town. There are 600 members at the golf club. There are 12 people on the board of directors, and the survey is given to all the 150 golfers who come to the club on a certain day. What is a population that this study is interested in finding information about? Okay, so if we're looking at this, they're telling us they're conducting a study to determine if the golf club members, are interested in remodeling the clubhouse. So we need to know how many golf club members there are. And if we look at it, we find there are 600. So the answer to this is D. Let's look at the next one. What is the sample used for the study? So 600 is the entire members of the golf club, but they only gave the survey to 150 golfers. So the 150 is our actual sample. So again, a sample is smaller than the population. A sample is part of the population, but not the entire population. All right, so let's look at this next example. By the way, these are going to look like your homework questions that you have. Use the graph to the right. So the y-axis, if you remember that from algebra, is going in a vertical direction, and the horizontal direction is the x-axis. So x is the data points, and y is a frequency. The first thing says, what is the class width? Okay, so the class width is how wide, and by the way, this is called a histogram. So let's get some verbiage done here. A histogram is a bar graph where the bars touch. Okay, so we can see, I'm going to rewrite that word touch because that looks messy. So let me fix that for you. The bars touch. Okay, so we're looking at a histogram. To find the class width, and this is why it's called a width, we're looking at how wide the bar is. So I'm going to take the upper limit and I'm going to subtract the lower limit from it. Okay, so the upper limit for the first bar is 4. Minus the lower, which is 1. So 4 minus 1 will give me an interval of 3. What is the sample size? All right, to find the sample size, we're going to have to look at all the heights of each of these bars that I'm highlighting, and I'm going to find out what the frequency is and add them up. So what does that look like? So for the first bar, going from 1 to 4, the height or the frequency of it is 8. So I'm going to do 8 plus. And then the second bar, from 4 to 7, I have 6 people. So plus 6. The third bar, from 7 to 10, I have 4 people. The next bar, or the fourth bar, from 10 to 13, has 10 people. The fifth bar, from 13 to 16, has 2 people. And finally, the last bar from 16 to 19 has 5 people. So now I have to add that all up to find the sample size. So 8 and 6 is 14. So I'm combining these two. 4 and 10 is also 14. And then 2 and 5 is 7. Okay, 14 plus 14 is 28. Plus 7 will give me a value of 35. So there are 35 people or things in this data set. Okay, so again, to find the sample size of a histogram, you find the height of the bars and you add them all up. Okay, so the bar graph below, which again is a histogram, shows the percentage of students who received each letter grade on their last English paper. The class contains 380 students. By the way, they just told you the sample size. So the sample size is everybody in the survey. So the sample size is 380. Then it goes on to ask you what number of students earned an A on their paper. Remember that the frequency is done in percentage, okay? So I'm just reminding you, this is percent. All right, so if we look at the x-axis, remember that x is the horizontal axis and y is the vertical. The x tells us the grades these students receive. So we have A, B, C, and D. I'm looking at the A bar, and I see that there's 10% of the class that got an A. So how do we figure this out? We take the sample, and we're going to multiply it by the percent of students that earned an A. Okay, so what does this look like? This looks like 380 times 10%, and we're going to find out what that equals. Remember that with percent, you have to change that into a decimal. So 10% is 0.10. Okay, and if I multiply that together, I'm going to get 38 students. So out of that 380 population, 38 of those students earned an A in the class. Okay? So again, we took the sample, we multiplied it by the percent of students that earned an A. So 380 is the sample size times the 10%. Okay, next one. A sample of people were asked how many pets they have. The bar graph below shows the number of adults who indicated each number of pets. So again, it's a histogram because all those bars are touching. The y-axis is the number of pets that these people owned. Okay? It says how many adults were questioned. Well, they don't tell us in the original information. So what I'm going to do is find the sample size. And to do that, again, what I'm doing is I'm adding up all of the heights of each of the bars. So I'm highlighting the height of the bar. Okay, so the number of pets, the person that has 0, there were 6 people. So I'm going to do 6 plus. And then the number of people that had 1 pet is 10. Plus the number of people that have 2 pets is 14. Plus the number of people that have 3 pets is actually between 10 and 12. So we're going to say that's 11. Plus the number of people that said they had 4 pets, which is between 4 and 6, which is 5. And finally, the number of pets, 5, that's 2. All right, so we're going to add that up. So again, 16 and 10, or sorry, 10 and 6 is 16. I said that wrong. 14 and 11 is 25, and 5 and 7 is 7. So I'm going to add these up. I'm going to go again, 16 plus 25 is 41, plus 7, this equals 48. So your sample size is 48 people. Okay, all right, now let's look on. What percentage of adults questioned had 2 pets? So to find the percent, I'm going to take the sample size, which we know is 48, and we're going to take the number of people who own the pets. So we have to find that. The number of people that have 2 pets is 14. And we're going to take and divide those two numbers. So it's going to be number of people, which is 14. Number of people that own 2 pets over the sample size. And the sample size is 48. Okay, so I'm going to divide that. By the way, I'm using my calculator right now, so hopefully you have one out. Or you can use the one on your phone. So 14 divided by 48 equals 0.291. So I'm going to round it off to 0.29. And I have to change that to a percentage. So 0.29 in percent is 29%. So that is the answer to that question. So I'm going to put a little box here just so you guys know that this does not go into the next particular one. Okay, so now let's look at the next homework question. During one shift, the express lane clerk recorded how many times customers violated the 10 items or less rule for his lane. In particular, he recorded how many times over the limit each violator placed on the conveyor belt. This data is summarized in the histogram below. Note, the last class actually reported 7 or more items, not just 7. Okay, so the first question they ask you, what is the most frequent number of over the items for this data set? So if we look at it, when they're asking most frequent, we're looking for the highest number. So if I look at that, I'm looking at the tallest one, which is that 4.5 to 5.5 or 5 items. Guys, so that's like, I'm guessing 13 because it's over 12, but it's not quite hitting 14. So we're going to say that's 13. Okay. 13 items. But it's asking us what is the most frequent number. Okay, so that's the frequency is 13. But the items, we're going to go back to the x-axis here and see it's between 4.5 and 5.5. So the items are 5. So 5 items over the limit. Okay, what is the frequency of the most frequent number of over the limit? The frequency is the 13 items. Okay, so just to reiterate for clarity, 13 is how many times that happened, and the number that is associated with that 13 times was 5 items over 10. Okay, all right. So by the way, that closes out this section. You're welcome to watch it as many times as you want. And the next section we're covering is 8.2.